Hartmann Controls has designed and produced pressurized fluid control devices and systems for over 60 years. Founded in 1946, Hartmann soon developed the Hartmann roll vane motor for servo-hydraulic positioning and metering applications. The roll vane remains the most precise hydraulic motor on the market. In the 1980s, Hartmann purchased Delavan's piston pump product line and followed that up in the 2000s with the purchase of the radial and vane motor product lines from General Technologies. In the 1990s, Hartmann introduced our own patented inboard piston pump to replace the Delavan design. In addition to hydraulic pumps and motors, Hartmann produces a wide array of specialty valves and controls for the construction, railroad, military, marine, and machine tool industries. Throughout Hartmann's history, we have strived to move the bar to higher and more precise fluid control. Today we are going to demonstrate our patent-pending Hartmann Series 12 Dri-Line. The Dri-Line was developed for applications where the fluid remaining in a supply hose needs to be drained due to an external requirement or condition. These conditions could be protection from freezing, viscosity changes, reactivity, safety, etc. The advantage of the Dri-Line concept is that it removes the need for draining, because when the supply is removed, the fluid resident in the Dri-Line is quickly forced out of the line into your reservoir or tank, thus eliminating the need for buckets, additional special valving, labor to drain, and the resultant spills and spill cleanup. The system Mark is about to demonstrate is incredibly easy to install and use and can work with a wide variety of fluids and conditions.
The Dri-Line design centers on a dual hose concept in which the inner line carries the supply fluid to its destination. The inner hose is surrounded by a system fluid which is linked to an accumulator. As you can see, the inner hose is collapsed and there's no fluid in the line. The system fluid is pressing in on the collapsible hose, keeping it in a compressed state. Once the supply pressure is initiated, the inner hose will quickly expand and expel the surrounding system fluid back up into the accumulator. The pressure in the accumulator is small enough that it will not restrict the flow of supply fluid. When this happens, the air in the accumulator will be compressed and the pressure will rise. This rise in pressure is the energy that will eventually be used to evacuate the remaining fluid in the hose. As you can see, once the inner hose is completely expanded, flow will be at a constant rate and the accumulator is half filled with system fluid. Once the supply pressure is shut off, the pressure in the accumulator immediately starts to compress the inner hose. In only a few seconds, the hose is collapsed and the remaining fluid is evacuated. This process is accomplished without the need for any additional electrical or mechanical input. Now let's take a look at the prototype.
Shown here is the prototype for the Hartmann Dri-Line. The system consists of a hose inside of a hose. The inner hose is collapsible and leads up into the tank. The outer hose contains a system fluid which is directly connected to the yellow accumulator. The quick disconnect is supplied by a garden hose with water at about 50 psi. I'm going to turn the hose on. The hose expands. The tank begins to fill with water. The accumulator is now at a higher pressure because when the hose expanded, it forced the system fluid up into the accumulator. The air pressure is higher in there now. When I turn this off, the pressure is now pushing down on the inner hose, collapsing it. Within a few seconds, the entire hose is completely collapsed. The remaining fluid inside the collapsible hose is evacuated into the tank with no additional electrical or mechanical input.
Now let's take a look at what's happening up by the tank during the process. Once the supply valve is opened, a few things happen simultaneously. First, you see the inner hose expand as the supply fluid starts to flow through it. At the same time, the pressure gauge on the accumulator rises as the system fluid flows up into it. The tank is slowly being filled with the supply fluid, and if we go back down and shut the supply valve, the supply pressure drops and the accumulator pressure starts to empty the line. Back at the top, you can see there's still water coming from the hose even though the valve is shut. This is the fluid that would normally be left sitting in the hose. Here you can see the hose is fully collapsed all the way up to the tank. Here's another view from the ground when the supply valve is opened. The hose expands, pushing the system fluid up into the accumulator while the supply fluid flows into the tank. The valve is shut and the inner hose slowly drains. The system is designed so that the line can empty slower or faster. One advantage of a slower drain is to ensure that the hose closes from the bottom up and no fluid gets trapped at the bottom. This could be especially crucial in situations where freezing is an issue. Depending on how long the hose is, it's probably not efficient to keep the entire line heated. This way, after filling the tank, the operator can walk away and not worry about fluid freezing in the line or failing heating elements. For more information on the dry line, feel free to contact us here at Hartmann Controls. Thanks for watching.